Alright, so this is project 2, the temperature sensing project with the Arduino for embedded systems class in the spring of 2020. We're just going to go through the requirements. I didn't add very much to this project either. The first requirement is that the Arduino will record the ambient temperature and that it will use a calibrated temperature sensor. I'm using the DHT11 sensor. This is already calibrated, though the readings are in Celsius, so I'll need to convert those to Fahrenheit. The implementation needs to use a round robin with interrupts design, and so I'm going to be using a timer interrupt to manage that requirement. The time and temperature should be transmitted across a serial bus to the host. I've got a USB connector, and the Arduino is going to take temperature readings at a periodic rate, so I'm going to have this happen every 10 seconds. For the demo, I'm going to leave the temperature sensor out at room temperature. I'm going to take about a minute's worth of recordings. Then I'm going to move the Arduino with the sensor into the refrigerator. I'm going to record for 5 minutes. Afterwards, I'll take it out of the refrigerator and record temperature for another 5 minutes as it stabilizes back to room temperature. The total recording time of this is about 700 seconds, and I'm just setting that limit so that I can make a real-time graph. I'll be doing this real-time graph in Python using Jupyter notebooks. And finally, I'm going to save all this data off as a CSV so that a user can export the data and then load it into another spreadsheet software as they choose. As far as hardware requirements, I'm using an Arduino Mega 2650. If you're going to run this on a different Arduino, you may need to modify the timer interrupt code slightly. I'm using the timer 4 16-bit timer on the 2650. You'll need a DHT11 temperature and humidity sensor, 3 jumper cables, a breadboard, and then of course a laptop and a USB cable. These are the schematics that I took from a very helpful site, circuitbasics.com. That's also where I got my DHT11 software library, which is something we'll need later. The way this is going to work is this DHT11 has 3 pins, a signal pin, which I'll connect to digital pin 7, a VCC pin, which I'll connect to the 5-volt energy source, and the ground pin, which I'll connect to ground. So the power is coming from this VCC pin, and then it's going to be reading in the temperature and transmitting that data to pin 7, where I'll then read it and transmit it through the serial port. There's already a resistor on this sensor, so I didn't have to think about that. For software, I'm going to write my code in C using Arduino Sketch, and that's how I'll get my temperature recordings and convert things into Fahrenheit. The graphing and plotting is going to happen in Python using a Jupyter notebook. The additional software that you'll need to run this is this DHT11 zip, as I showed you, which comes from the circuitbasics.com, but there's plenty of other places you can find that. To import it, you'll just go to Arduino Sketch, and I'll show you how to do that. Sketch, include library, add zip library, and that's where you will add it from. Now we'll walk through the code a little bit, and I'll show you how I am doing this. So we can just go to the code. So the first things that I'm doing are initializing my DHT variables, and something really important for my interrupt handling is that I have this Boolean get temp, and then I have seconds, and both of these need to be volatile so that they can be used in the interrupt handler. I'm defining my DHT11 pin as pin 7 because that's what I've got connected on my Arduino, which I'll show in a minute. I want to set up my serial port, and this timer interrupt code is all something that I got from this site, instructables.com, which explains interrupts. I'm going to be using a clear timer on compare match or CTC mode interrupt, and specifically for the Mega 2650, I saw an implementation that I liked here on this Arduino users forum. The crucial thing is that for the 2650, timer 4 is my 16-bit timer rather than timer 1 if you're using an Arduino Uno. So that changes some of these variable register names, and I'll walk through that right here. So we're going to stop interrupts while we set this up. We zero out our registers, and this important one here is the compare match register. So what I want to do is I want to have my interrupt happen every second. So I want a 1 Hertz frequency, and that means that I'm going to need to use this 1024 prescaler and follow this formula to get my compare match register set correctly. This is where I turn on the CTC mode, I set my prescaler, and then I'm going to enable my compare interrupt timer. And now I'll allow interrupts again after this is done, and so everything's all set up. So my interrupt handler is very simple. All I'm going to do is I'm going to increment the seconds, since this interrupt is happening once every second because of my 1 Hertz rate. I will just increment seconds, and since I only care about multiples of 10, if I am at a multiple of 10, which happens this little bit of modular arithmetic, then I'll set my get temp variable to true, otherwise I'll leave it as false. And now in my loop, if the get temperature is true, now I'm going to deal with taking my temperature reading. So I'll get my time seconds, which comes from the interrupt handler. Then DHT read 11 allows me to access the quantities that the sensor is reading in. So I care about temperature. I convert from Celsius to Fahrenheit, and then I'm just going to print the time, a comma, and then my Fahrenheit temperature. And what that's going to do is, in my Python code, I'm going to be able to read that in from the serial port. And then I'll get temp is now false, and this will just continue every time the interrupt happens. Get temp will be true, and I'll read my temperature reading. Otherwise, I'll just do nothing in the loop. I'll be waiting for the interrupt handler to set this to true. So once this data is printed to the serial port, I decided it would be easiest if I were able to plot the data in real time. And so I got help with this from this GitHub, Brandon Curtis, who does an example of this. And so in my Jupyter notebook, I'm going to import this serial library, PySerial, which I had to pip install earlier. I'm going to set up a serial connection. I'm on COM3. My baud rate is 9600. This is just a little bit of error handling. And now I'm going to initialize a plot here with time on the x-axis and temperature on the y-axis. And now while run is true, and run is going to go for a duration that I've set to be 700 seconds, I'm going to read in each line of my serial data. I'm going to split up the data, and then I have to do a little bit of data handling, some formatting, and then I'm just going to add those to my Y data and my time points arrays, which I'll plot, and this plot will continuously update. And then at the end of the 700 seconds, which is just the time for the demo as I specified, I'll plot all of my data, and then I will close up my serial connection. And here's just a little sample plot of what we might see later as we're running the demo. And then I'll print everything to a CSV, which will look something like this. It'll just have the time in seconds followed by the temperature, and that'll be available to export or download for the user. So I'm going to switch views now and actually run the demo and show you how this graph is updating live with the temperature readings, and then we'll go from there. So here you can see my Arduino set up with my DHT11 temperature sensor on this breadboard. Kind of lift it out a little bit so it's easier to see. I've got these 3 jumper cables. So this orange one, that's connected to the serial pin of the DHT11, and I've got that connected to digital pin 7. Then my green cable is connected to the VCC pin on the DHT11, and so I've got that connected to my power source. And then the red pin is connected to ground, and that's connected to the ground pin of the DHT11. So that's what the setup looks like, and then obviously connected to the laptop. So I've actually already started running this. I uploaded my sketch, and so what we can see here is our temperature graph. Every 10 seconds, it's plotting another point, and this is happening in real time. So the temperature is stable. It's about 75 degrees here in my room. And so these points are just going to continue plotting on this straight line. And now we're going to transition and move this Arduino into the fridge. So unfortunately, I don't have a very long cable. So we've got the Arduino here by the salad dressing. We'll close it into the fridge right now. And then I've got my laptop set up. And you can see the temperature is already starting to fall, and it will continue to drop until it reaches the temperature of the refrigerator. We're going to leave this in here for a few minutes. I won't force you to wait in real time, so I'll just speed this video up a bit as it goes. As you can see, as it's been in the fridge, it's been getting steadily colder. And so now we're going to take it out of the fridge, put it back in a room temperature situation, and watch the temperature climb back up. So now the Arduino is out of the fridge, and if we go back to our temperature graph, we can see it's starting to increase now as the Arduino warms back up to room temperature. The reason we're seeing this step function is because of our 10-second interval. If we were checking our temperature reading more frequently, we would probably see a much smoother curve as the temperature changed more gradually. And that also has to do with the error rate of our sensor. The DHT11 advertises about a plus or minus 2 degree temperature sensitivity. So within that range, it's possible that it's missing very small variations in temperature. So now it's been 700 seconds. We can see that we're almost back up to room temperature. It took me a little long in the beginning here to get the demo set up, so we don't get to see it complete, but you can get the picture. And what I'm going to do now is I'm going to just export this data to a CSV, and then the users will be able to export the data. So in future iterations of this project, I might make my 700-second window a bit longer to give myself more time to set up, but that's the entirety of the project. Thank you very much.